Okay, very well. So we'll be looking at another question that deals with condition for perpendicularity. It says P with coordinates 3, 4, and Q coordinates -3, -4 are 2 points in a plane. So we represented them here, PQ. Find the gradient of the line that is perpendicular to the line PQ. So there's another line. In this case, I've labeled it AB that is perpendicular to PQ. So how do we obtain the gradient of the second line AB? Now, we should know that let's denote this x1, y1. Here, let's denote this x2, y2, respectively. So recall that gradient, by definition, simply is, so recall, gradient indicated as M is, let's call this one M1, is equals to change in Y. We could use increase or decrease, but a more generic term to use is change divided by change in X. Okay, very well. So this is what we have here. So let's say M1 is equals to, so M1 is equals to Y2 minus Y1 over X2 minus X1. Okay, so Y2 is -4. So this is -4. Y1 is 4 minus 4 divided by X2. X2 is -3. X1 is 3. So basically we end up with -8 over -6. Then when we reduce this to their smallest, then we'll have -4 divided by -3. So therefore, we now say M1 is equals to 4/3. Good. Now, but we should also recall that our condition for perpendicularity is that the product of the gradients M2, M1 is equals to -1. So we've obtained M1, which is the gradient of this line, PQ. We need to find M2. Okay, so we just substitute there M2, okay, times M1, 4/3 is equals to -1. So we cross multiply this and we arrive at the final solution that M2 should be -3/4. Okay, how do we obtain this? We know that this one will give us 4M2 over 3 is equals to -1. So all we need to do is to simply cross multiply and we obtain M2 to be -3/4. So that gives us option A. So this helps us to understand how to solve perpendicular lines given their coordinates. This is how you obtain the gradients using the condition for perpendicularity.